Okay, so we're going to look at how we can use a for loop to generate the Fibonacci sequence of numbers. Okay, so I've written the for loops by hand so far, but we can actually get a shortcut to an exemplar for loop code by using the for I shortcut in IntelliJ. It will ask us to insert the condition, but it will start at 0 and increment I. Okay, so let's say we want all the Fibonacci numbers up to 144. Okay, so how do we do that? Well, we can start with I equals 1, and we also need two numbers to start with, so we can say j is equal to 1. Okay, the other thing we can do is actually we're not required to have any of these particular statements. We do need the semicolons between them, but because we're going to do logic that's a little bit more complicated, whereby we're going to transfer the value of I plus j into a total variable and then shift them along, it's probably clearer to do that in the loop. So I'm going to omit that option. So if we think about a Fibonacci sequence, we need to, in each step, sum these two numbers, move j into I and put the total into j. So that looks something like this. We could say int total equals I plus j, and then we could say I is equal to j and j is equal to total. Okay, obviously I still need to print out the value of I, so we get the printout of the Fibonacci sequence, but that should solve the problem. Okay, so we can declare two variables there. We've got our condition for I we're caring about, we're going to stop once I gets to, or so it goes up to and including 144, and then we've got our logic to solve the problem here. So let's just run that. And there we go, we can see we're getting the output. So again, the important thing is we don't need any of these statements. It's also possible, for example, to do this. Okay, so we're missing out the initialization statement, that's the first one. We're missing out the continue condition, and we're missing out the increment statement. Okay, so if we do this, our code will run essentially forever. So if I type hello there, we'll just comment out our Fibonacci generator for now. This code will keep going forever because there is no condition upon which we would stop running. Okay, we can also get out of a loop by using the break statement. So we might say, for example, we could ask the user, do you want to continue? Do you want to continue? We could have a scanner to read their answer. And we could use that scan to read in a Boolean. So if we want to turn to type true or false. If we've got to read it in first, so Boolean continue. So that's an interesting one. Continue is a keyword in Java, so we can't use it as a variable name. So the important thing here is to choose a name that's similar. User continue, for example, and then we could say scanner dot next Boolean, and then we could say if not user continue break. So if we run that, we say true, our loop continues, but if I want to exit, we can exit with the break statement.